You're welcome in your maths, and I got a new problem. Today we are going to discuss pair of linear equation in two variables, consistencies, criteria. So let's go. So this is pair of linear equation in two variable, in which linear means highest degree is 1 and equation means comparison between two expression. But in class 10th we basically read about comparison between two polynomials, and because it's also a standard form of comparison. And here it is pair of because we need two equation to solve the value of two variables. Now pair of linear equation in two variables sometimes inconsistent, means when you solve the pair of linear equation you get no solution, means x and y value is not possible. When this kind of condition happen, then no solution happen and it's inconsistent. And sometimes it becomes consistent, means by solving pair of linear equation in two variable you get some solution. And if this condition happen in pair of linear equation, then due to this condition many solution happen and it becomes consistent because it has solution. And if in these equation this type of condition happen, then it has a one solution and it is consistent because after solving the pair of linear equation you get some solution. Remember, there is two variable, therefore you need pair of linear equation or two linear equation to get the value, and you can get x like this. Okay, and this is a standard form of writing the linear equation. Now how particular type of criteria work? So first of all we will discuss this many solution criteria. So when this type of consistency criteria happen, then you get many solutions, means after solving the pair of linear equation in two variable, means when you solve these two linear equation in two variable you get many solution. But yes, this criteria happens, then it has many solution. Like example 1 by 2, 1 by 2, 1 by 2. Okay, so here you can see that a2 is double of a1, b2 is double of b1, and c2 is double of c1. When this happens, then it's become 1 by 2, 1 by 2. Okay, but in actual a2 is anything multiple of a1, so let's say x, so x into a1, so b2 also x into b1, and c2 also x into c1. Now put these new value of a2, b2, c2 instead of this a2, b2 and c2. Put these values. Okay, so what you get? So it is x into a1 into x plus x into b1 into y plus x into c1 is equals to 0. Now take out x common and send x to the RHS, then you get the equation as a1x plus b1y plus c1 is equals to 0. And you can see that the first equation and second equation are same, so they both are coinciding lines. Therefore at every x you get the same y in both lines, hence it has many solution and it's consistent because it has solution. Now let us discuss this criteria due to which the pair of linear equation, after solving the pair of linear equation you get one solution or unique solution, and as you get solution so it's consistent. Okay, so in this a1 by a2 is not equals to b1 by b2, and in this two lines intersect each other at a single point, and the value of the x and y at that intersection point is valid for both equations, means it satisfies both equation, therefore it has one solution. Now let us discuss why they intersect at a single point. So if you can write any linear equation in two variable in y is equal to mx plus c form, then you can get m, which is slope of the line, means you get theta inclination of the line from the y-axis. We will deal this later on the video. So here I have written the first equation as in the form of mx plus c, in which m is minus a1 upon b1, and for the second equation it is minus a2 upon b2. You can also check it, so you can clearly see that the both slopes are different, hence inclination theta are different, and they intersect and gives you one solution. Now let us discuss the inconsistent criteria of pair of linear equation in two variable. In these two parallel lines are formed, therefore no solution exists as they never intersect. In this a1 by a2 is equals to b1 by b2, let's say it's 1 by 2 is equals to 1 by 2, and in this a2 is equals to double of a1 and b2 is equals to double of b1. But in actual ratio can be anything, so let's say a2 is m times of a1 and b2 is m times of b1. Now let me write the pair of linear equation in two variables. So the first equation is something like that and the second equation is something like that. Now the slope of the first equation is as I have proved it in the previous slide, and I will also deal the slope concept later on the video. So the first equation slope is minus a1 upon b1, as you can see here, and the slope of the second equation is minus a2 upon b2. So the second equation slope is minus a2 upon b2. And you can see that through the use of this criteria I have written a2 and b2 in the form of a1 and b1. So I write here minus m into a1 and b2 as m into b1. So cut down and it becomes minus a1 upon b1. And you can clearly see that the slopes of the both lines are same, means the theta inclination of both lines from x-axis is same. So we can say that if slope same, then the inclination theta from x-axis will be also same, and the rate of change in y with respect to x will be also same. Again, I will discuss these things later on the video. So you can see these are parallel lines. But if the C1 is to C2 ratio also equal, then these two lines submerge, means both coincide, and gives you many solutions. Now let us discuss how and what is slope form of linear equation in two variable. Now let me draw a graph and let me draw a line which is representation of linear equation in two variable. So this is the standard form of writing the linear equation in two variable. Now let's discuss the slope concept. So what is slope? Slope is basically tan theta, means this theta, okay, theta inclination of a something line from x-axis. Now let's suppose at y1 and let's suppose at y2. Let's suppose at y1 we get something x1 and let's suppose at y2 we get something x2 value. So if I produce this parallel line, then this is theta, then this is theta as well, because they are corresponding angle, and this length is y2 minus y1 and this length is, this whole length is x2 and this length is x1, so this is x2 minus x1. Now in this triangle you can see tan theta is equals to what? Perpendicular upon base, which is y2 minus y1 upon x2 minus x1, and that is rate of change in y with respect to change in x. It means how much y changes with the change in x, and this change always remains the same because the inclination theta from x-axis of this line always remains the same because they all are corresponding angles. Now let us solve this linear equation in two variable, and now let us try to find out at y1 what happens. So at y1 x is x1, so at y1 it's minus a1 x1 upon b1 minus c1 upon b1, and as you know, when you put y2 you get x, which is equals to x2. So y2 is equals to minus a1 x2 upon b1 minus c1 upon b1, in which c1 upon b1 is constant and also same. Now what we will do is we will subtract y1 from y2. So when you do this, you will basically finding the change in y. So y2 minus y1 is equals to minus a1 x2 upon b1 minus c1 upon b1 plus a1 x1 upon b1 plus c1 upon b1. This cancel out, and when you take minus a1 upon b1 as common, you get minus a1 upon b1 bracket x2 minus x1. Now send x2 minus x1 to LHS, then you get rate of change in y with respect to x, and that is what we call it slope, which is tan theta. Now from this equation we get y is equal to something like that. Now rewrite it, y is equals to minus a1 upon b1 x minus c1 upon b1, and in this you can see that this one is the slope. Now slope is generally represented by m, so this is mx, and plus this whole can be written as c because it's constant, so we can write it as c. So you can see that y is equal to mx plus c will be its slope form of linear equation in two variable. Hopefully you get it, so don't forget to like and subscribe.